What's up guys, this is Massey. Welcome to another video. In this video I want to talk about basics of trigonometry, and I start with trigonometric ratios. So what are trigonometric ratios? We have three trigonometric ratios, three main ratios. One of them is sine, one of them is cosine, and one of them is tan. How do we define that? If we have a right triangle, and here we have a theta angle in here. When we are talking about right triangle, the side opposite to 90 degrees, we call it hypotenuse. The side beside the theta, call it adjacent. And this side is going to be opposite to theta angle. So now when we want to define sine, sine is going to be opposite divided by hypotenuse. So it's going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tan is going to be opposite divided by adjacent. So that's how we defined sine, cosine, and tan. We also call them SOHCAHTOA in order to memorize these three formulas. So means sine equals to opposite over hypotenuse, cosine ka adjacent over hypotenuse, and tangent is opposite over adjacent. We have three more formulas, which are secant theta, secant, cosecant, and cotangent. Secant, cosecant, and cotangent theta. Secant is inverse of cosine, which is going to be hypotenuse over adjacent. Cosecant is inverse of sine theta, which is going to be hypotenuse over opposite. And cotan is the inverse of tan. So that's going to be adjacent over opposite. So we have these six ratios. The second three ratios are called reciprocal trigonometric ratios. Let's see some examples. First example, I have this triangle, right triangle. This one is 4, this one is 3, and this one is 5. Even if we don't have this one, we can use Pythagorean theorem in order to calculate the length. Now if we have theta in here, somebody might ask, state the 6 trigonometric ratios for theta. So we're going to have sine theta, that's going to be opposite over hypotenuse, 3 over 5. We have cosine theta, that's adjacent over hypotenuse, 4 over 5. Then we have tan theta is opposite over adjacent, 3 over 4. We can even write it in decimals, 0.6, 0.8, 0.75. And the inverse of them, cosecant is inverse of sine, which is going to be 5 over 3, which is going to give you something around 1.66 or 67. Secant theta is inverse of cosine. That's going to be 5 over 4, which is going to be 1.25. And cotan theta is inverse of tan, which is going to be 4 over 3 or 1.33. So these are the 6 trigonometric ratios for theta. Let's see another example. We have theta in here, 5, 12, and if this one is not given, we can say, if this is c, we can say c squared equals to, and this 90 degrees, 5 squared plus 12 squared plus, so it's going to be 25 plus 144, that's going to be 169. Therefore, c is going to be square root of 169, which is going to be 13. So sine theta is opposite over hypotenuse, 5 over 13. Cosine theta, so it's adjacent over hypotenuse. Adjacent is 12. This one is 13. Tan is toa, opposite over adjacent, 5 over 12. I just keep it in fraction. I don't write it in decimal. Next one is cosecant, for example. Cosecant is the inverse of sine. So it's 13 over 5. We just flip this one. Secant theta is inverse of cosine. We just flip this one as well. 13 over 12. And cotan theta is going to be 12 over 5. So these are going to be the 6 trigonometric ratios for theta as well. Next example. State the reciprocal trigonometric ratios that correspond to sine theta is 7 over 25, cosine theta is 24 over 25, and tan is 7 over 24. So first of all, I need to write, for example, secant theta. Secant is inverse of inverse of cosine, which is 1 over cosine. So it's 1 over 24 over 25, which is going to be 25 over 24. Cosecant theta is inverse of sine. So it's going to be 1 over 7 over 25, or 25 over 7. Cotan theta is going to be 1 over tan theta, which is going to be 1 over 7 over 24, or 24 over 7. So next question. Write the corresponding reciprocal ratio. A. Sine theta is 1 over 8. The reciprocal ratio for sine is cosecant, which is inverse of sine. So that's going to be 8 over 1 or 8. Next question, cosine theta is 2 over 3. That's going to be secant, the ratio, which is 1 over cosine. That's going to be inverse of it, which is 3 over 2. See, tan theta is 3 over 7. So cotan is going to be inverse of it, which is going to be 7 over 3. Cosine is 5 over 3. The thing is, there is no cosine greater than 1 or less than -1. So that's not possible. So all sine functions and cosine functions are between -1 and 1, including both of these numbers. So it cannot be more than 1 or it cannot be less than -1. Now for next question, I'm gonna say write the primary trigonometric ratio. A. Cotan theta is √3. So tan theta is going to be 1 over √3. Or when you rationalize it, you need to multiply it by √3. Both numerator and denominator is going to be √3 over 3. Secant theta is 11 over 4. Therefore, cosine theta is going to be 4 over 11. C. Sine theta is √2 over 2. Cosecant is going to be inverse of it, which is going to be 2 over √2, which when you simplify it is going to be √2. And the last one, cosecant theta is 3. Sine theta is going to be 1 over √3. So if you look at here, this one, and this one are the reciprocal ratio, but this one was the primary trigonometric ratio. So at the end, if I want to write the range for trigonometric ratios, I'm gonna say sine theta is gonna be y equals to sine. It's gonna be YER. Y is between -1 and +1, including. Y equals to cosine theta is gonna be YER, and y is between -1 and +1. And tan theta is gonna be YER. That's just YER. There is no limit. It can be any real numbers. So these are all about trigonometric ratios, both primary trigonometric ratios and reciprocal trigonometric ratios. As you saw, we have 3 primary trigonometric ratios and we have 3 reciprocal trigonometric ratios. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.